Oh, hello everybody. This is going to be our last lecture. So as you know that this week is a revision week, so I'm going to cover the last topic, and it's going to be like theoretical discussions. I will provide you some information. Then our lecture will be over, and we can still meet on Thursday to make additional discussions if you need. And that's all. That's all. Okay. So if you don't have any question, I am going to start this lecture, and I will talk about urban hydrology for water distribution and water collection networks. And I'm going to introduce some principles, and actually not the principles today. I am going to talk about some technologies and some new trends, and also I will try to help you what could be the, what kind of future research options are available in this area, because you are young engineers, you are going to be young engineers, you might be interested in water engineering and water engineering applications. So that's why I like to make some additional discussion today and focus on those issues emerging in the sector. So anybody has any question? No, we don't have. And by the way,
about the assignment, the last assignment.
the last assignment.
Yes, it's like the last week before the finals.
Oh,
so
yeah,
maybe...
it is. I didn't upload it right. Thanks for reminding. I will do it as soon as possible today.
Okay.
Thank you, Tomiris. Good reminder. Just take me the note. I will take it out. I actually I was extremely busy during the last couple of days. I just totally forgot about it.
Yeah, I mean, just it will be good if we do it before the start of the finals.
Yeah, don't worry. I will give you extra time if you need. But I'm planning to give you some simple question because yeah, you are last year students, and this is your. No, you are not last year students.
No, third year students.
Third year students.
No more questions.
Thank you. So let's cover the topic for today. Okay, guys. So you know that the flooding, especially in urban areas, is not a kind of something you are not familiar with. I think most of the Kazakh people are well aware of that. This is always happening in some regions, especially in Kazakhstan. I took those pictures from internet, and it was taken by Isulu, Ushteva, and it seems that these are some places from Kazakhstan, some catchment, urban catchment areas. So the thing is that if you are living in a flat terrain, okay, you are likely to have flooding problems. And even if you are living not in a flat terrain, in a valley, it is again another problem. You can always experience such problems. So it's a part of some urban settlements, and it requires good engineering, okay? Good engineering. And the main principle is actually this: people need space, so do rivers. I mean, while the engineers are designing urban places, and I mean cities and towns, they, not engineers, but this is about us. People always prefer to stay close to riverside because river is the main source for drinking water and main source for cleaning, and also main source for sanitation. So that's why, I mean, historically, all the civilizations, they prefer to stay around the river basins, but it also comes with risk of having floods. Okay, so also many civilizations, many cities and towns are suffering from the floods. It doesn't happen every day, but it is likely to have a flooding event in a short period or long period. So it requires good engineering, designs and strategy. So I strongly suggest you to make a kind of reading about the urban hydrology systems, which is given in the bottom of the slide. If you can find it, it might be good reading for you. So the good design means also good urban catchment areas for flood events. And as I told you that every city, every location, every town has different characteristics in terms of climate, terrain, size, and the management systems. Well, as an engineer, guys, you are first supposed to make a kind of good analysis for causes and possible effects. And it is our responsibility as civil engineers. We have to provide the best engineering skills for the given problem. And the given problem for Kazakhstan is flood. Okay, so there are lots of flooding problems in everywhere. It means that most of the cities are not well managed, not designed well. So as you are engineers of the future of this country, you are responsible to make more sustainable urban infrastructure designs, focusing on good urban runoff and stormwater management, and making good and sufficient land use planning. Then it will be possible to improve the safety and health of the public. You can also reduce the expenses in terms of electricity cuts and also traffic blockage. And also you can reduce or minimize the damage on the built environment, which can easily happen during any flooding disaster. I mean, actually, this is in the list of disasters. So how it is going to work? I mean, technically, I'm not going to go into details. As I told that today, I'm just going to provide you some insights and ideas, what you can do, what you can focus on in the future if you're interested in this area. So everything is attached with a good land use planning. So you should do a kind of flood estimation first. It requires rainwater data analysis, as I introduced in the earlier week. And then you can use some tools and models to make hydraulic modeling. Okay, it is possible to make a kind of hydraulic modeling in one dimension or 2 dimensions. And recently, the underground water dispersion is added. It might be also possible to make a kind of 3-dimensional modeling. And you can use GIS tools and analysis to make a kind of good management on the water catchment areas. You can create flood hazard maps by using GIS tools powered with modeling techniques. And then, of course, there is a kind of always digital production and reporting and analysis based on reporting the analysis based on your findings. And all those skills are soft skills recently developing. And for example, if you are a GIS expert, you can easily fit in many positions in the government. They're always looking for best GIS experts. And if you have some experience in flood hazard map, it provides additional benefits on the top of GIS expertise. So these are some soft skills you can gain as an engineer. I am sorry to say to you that we don't have any course at the moment in Nazarbayev University to offer those things. Maybe in the future we can do that. Maybe at master level if you are interested in. But also we don't have a master program for water engineering, just dedicated to water engineering. But what we are offering at the moment, a kind of general engineering master program in engineering, civil engineering. You can join our master program, but you can get some specification or specialization on water engineering issues if you are interested in. Okay, so it is also important to know that what is sustainable urban drainage system. And I'd like to take your attention on the sustainability term. It is here because you know that sustainability is a kind of terminology optimizes, or let's say maximizes economic, environmental impact, and social benefits. So that's why if you are making a kind of urban drainage system, you should not only focus on the economy. I mean, a cheaper solution is not the best solution. You should also focus on that it is the best for the environment. It's also best for the society. Society means that minimal damage during heavy rain events. And it is quite a dynamic process. It is almost impossible to copy and paste one project to another place. Every city, every town, every district should be analyzed by its own characteristics. That's why this research, this area in terms of engineering is a kind of quite dynamic engineering and well-paying area too. For example, if you're a kind of engineer, okay, working and having experience on construction business, okay, you can have a kind of good and wealthy life. But if you are a good engineer in water infrastructure, okay, you will be a rich man or woman in the future as an engineer, because this is one of the best paying engineering discipline because the infrastructure projects are complicated and it requires the best expertise. It also takes a little bit longer time to gain the expertise than the regular engineers. For example, you can do a civil engineering work for construction projects after your graduations, but it is almost impossible to be a good water structure engineer after your graduations. It requires extra education and training on water infrastructure in a master program, maybe in a PhD program, or in a good company. Maybe also you realize that this information on the information on this slide is aligned with the earlier presentation. I mean, this figure. So the sequence of the activities or how they are related to each other, it starts with developing a database. Actually, we are not the engineers developing the database. Mostly we are getting those database from hydrology engineers or hydraulic institute agencies from national level, like Kazi Hydromet, Hydromet. I don't know how do you call it, Kazi Hydromet. I think you call it Kazi Hydromet, right? Kazi Hydromet.
Yes.
Yeah, Kazi Hydromet. You can get this data and database from them while you are making a kind of analysis for an urban level. Then you can develop an urban hydraulic modeling. So we don't have such urban hydraulic modeling in most of the cities in Kazakhstan. So it is a very interesting area to focus. Then also you can make a kind of design for for precipitation data by using meteorology data. Then you can make a kind of analysis for sustainable urban drainage system for the given characteristics. Then you can make a design. You can suggest a kind of good design. So I will vote forever. Actually, I am offering one more course. You can take it next year if you want. It is selective elective course, okay? And in that course, I am actually it is a different course than common or conventional courses. We are following totally different the methodology. First, I am using flip chart method, so not flip chart, flipped classroom method in the course. The second thing is that the course is just designed to explain you how you can make a kind of water infrastructure, water supply system design. Okay, so it doesn't mean that it means that I am not teaching theory, but I am teaching you the theory in a sequence or in an order to explain you every stage of the project how you can do that. So you are starting from selecting a town on a map, a real town, a Kazakh town. Then you are at the end of the course, you are ending up with a totally designed water supply infrastructure project. So this is actually a very good experience, and there is no other or equivalent course in this country. As far as I know, there is no other professors are teaching such courses, so it's a great experience if you like to join that project, that course. The name of the course is Water Supply Engineering or Water Supply and Management course. Okay. So one more thing to do to talk is today the green infrastructure. Actually, in the earlier slide, I mentioned your sustainable, okay, infrastructure, and now we are talking about green infrastructure. Green infrastructure is another narrowed down application of sustainability. So sustainability is at the higher hierarchy. So green infrastructure is sustainable term covers green, okay, but green is more specific, but it's quite interesting. You can make a kind of green infrastructure design even for water engineering. There are not such applications in everywhere in the world, but as far as I know, Netherlands is one of the best example country in the world applying green infrastructure for water supply, water drainage systems, water runoff systems. So it is quite an interesting research and interesting reading topic. So I strongly suggest you to make some research on green infrastructure. I mean, I'm not talking about buildings. I'm talking about water infrastructure, okay, green water infrastructure. And there are lots of benefits to have green infrastructure in relation to the water. As I told you, that this is quite a new terminology, and there are many. It is challenging for many, even for many developed countries. But some developed countries are very good at this, and they are making lots of good applications, and they are enjoying with the benefits. The benefits are not only related to cost savings or cost efficient solutions, but also it provides additional job creation and innovation opportunities. There are lots of spillover effects going from water infrastructure to, for example, energy efficiency, climate change, and smoke reduction, heat mitigation, and health benefits. Also, it provides good flood protection functions and water efficiency practices. So I will not go into details because of the limitation of this course, but these are just quick information for you and new terminologies to open your mind on the discipline. I think you are aware of that. Okay, in our civil engineering program, guys, there are disciplines. Okay, for example, construction engineering, one discipline. Okay, geotech knowledge is another discipline. Project management is another discipline. Environmental engineering is another discipline, and water engineering is the new discipline. I mean, we established this discipline 2 years ago, and it is the second year today to this year, and it's going to grow and it's going to develop fast. I am pretty sure that there will be some other professors in the future teaching water engineering, water infrastructure, and water lectures, water engineering lectures. But this is a fifth discipline in civil engineering program. And if you ask me that, it is, I think, one of the most important discipline in the program, because water engineering skills and good engineering practices are utmost important in Kazakhstan. Everybody, as I told you, that everybody can design. All the civil engineers can design easily some construction and housing projects, but it's quite challenging to raise good engineers in this discipline. Okay, so in this slide, this is the last slide actually. I'm going to provide you some good practice in water and green infrastructure applications. We are still talking about green infrastructure for water engineering. So what you can do, for example, you can design vegetated rooftops, green roofs, or blue roofs. I don't know, I am pretty sure that you are familiar with green roofs. Maybe this is your first time to hear what is blue roof. Okay. So blue roofs means that, okay, the roofs are used as a kind of detention tanks. This is a kind of quite a new technology and methodology. It's a little bit risky in design of buildings, but still there are lots of building designs all over the world. They are applying this principle, and it's quite interesting to look. And also you can do roadside plantings, absorbing gardens, and also you can use some new materials in conventional construction of infrastructure to capture, filter, and reduce the stormwater, such as permeable pavements, porous asphalts, or pervious concrete. I mean, these three materials are quite interesting. Please, I invite you to read those, watch those videos. You are going to find it quite interesting. For example, if you are talking about porous asphalt means that it is like conventional asphalt, okay? It is asphalt actually, but when it rains, it absorbs the water as a sponge, okay? So water directly goes into the asphalt and penetrates under the asphalt, and the asphalt itself, road itself or asphalt cover is itself working as a water catchment basin. So this is very good and promising solutions. There are such new methods in everywhere in the world. They are applying, especially in the UK. They are leading those technologies and those applications. You may find them very interesting. Please read and please do some digging. Do some research, and you will understand the extent of those new terms and applications. It's also possible to design the infrastructure for rainwater harvesting, rain gardens, and bioswales. Urban tree canopy is also another important component in designing green water infrastructure. It might be also possible to attach or make some designs for green parking lots and green streets. So these are some concepts for, in relation to the green infrastructure. So guys, it is the final. It was the final the topic I like to cover, and it is over now. And I can basically tell you, okay, I am simply telling you that the lecture is over. All the contents are covered as it is planned. So we have nothing left behind. I am going to upload your last assignment as soon as possible. It's going to be easy one, don't worry. Just, I am going to give you one simple question to bonus you, okay? I know that you are busy, this is the end of the semester, but this is also one of the main courses. And as you remember that hydraulics and hydrology is not an easy course. I think it is one of the toughest courses in civil engineering program. but I made it my best to make it easy for you because this online teaching is limiting us. Okay, so it will be totally different experience if you were in real classroom. Okay, I mean, I will be pushing you more with more examples, more challenging topics, but I think this content is good enough for you for online learning, and I hope to see you on the next time physically in a real classroom environment. And also, I have one more news for you. I am not quite happy with the midterm exam and its results because it seems that lots of people are cheated, as I told you that, but I didn't start any disciplinary action because I do understand the position of this online exam. It's easy to cheat, and some students are just taking the easy solution rather than learning and challenging himself or herself. So that's why I decided to give you an exam on the final. It is not going to be the same exam, okay? It is going to be online exam, but you are going to have multiple choice questions, and you are going to have multiple questions, like maybe 50 questions or 60 questions. There will be time limitation, so you will be given very limited time, okay? Because if I give you time, it is going to happen in the same way. I mean, students are going to cheat. The questions are going to be simple, like multiple choice exam questions. Let me give you one example. For example, I will provide you the parameters, and I will ask you that what should be the Reynolds number, okay? Then it is just 1 minute calculation. You are going to calculate Reynolds number and you will provide. Or I will provide you the numbers and I will ask you that if this flow is turbulent or laminar, okay? Then you should be able to calculate Reynolds number and just write it is turbulent. So these are going to be a kind of simple question and simple answer type of system. You are going to have more questions than like 4 or 5, but it will be on Moodle. It is going to be multiple choice. There will be true and false questions, multiple choice questions, matching type of questions, okay? Or word missing word filling questions. So I will switch from conventional exam to that multiple choice exam. It is required because I know that I am not happy with the students. They did during the midterm exam. So I decided not to report it for the school as a kind of disciplinary action. But instead of reporting it, I am going to change the exam type for the final exam. And this is what you are going to get it. Okay? Any questions, please?
Should we submit any solution?
Sorry, Tomiris?
Should we submit any solution that we made, for example, for Reynolds number?
Yes. Don't worry. The exam is going to be dynamic. You are going, if you find the solution, there will be options like A, B, C, D, and you are going to select your solution if it is correct. Okay, for example, if you calculate 20, then you will find the 20 in the answer and you will select it. It is going to be like multiple choice exam. Okay, it's quite fair. And one more thing, guys. Sorry, Tomiris, I am going to listen again. Okay, one more thing is that this type of exam is quite standard exam in engineering certification programs for example, in the US. For example, if you go to US and if you like to work as an engineer, you have to take a certification of engineering diploma. So you are taking a kind of ABIT certification exam. In every state, they have different exams, but all those exams are multiple choice exams. And for example, they are also asking 20 questions from hydraulics, 20 questions from hydrology. Okay, and it seems that in all over the world, engineers are qualified and certified by multiple choice exam. So I thought that it's also feasible for our course, and I will do it for this course too. And don't forget that your time will be limited. It means that if you are busy, if you keep yourself busy with the other students' answers or helping them, you are going to lose your time because Moodle is automatically shuffle all the questions. It means that questions will come in different orders for every student, okay? And also answers are going to be in different order. I mean, for example, it could be answer could be choice A in your question, but it could be different for Tomiris, okay? For you, for example, it could be option B. And one more thing, Moodle is also able to create some dynamic questions for everybody. So it means that, for example, if I ask you a kind of Reynolds number, you are going to get different numbers for every student, okay? Because Moodle is going to create a kind of different numbers by the given area, given limits, given rate, given ratio, given ranges, then most probably you are going to get different numbers for all the students. And one more thing, I am going to prepare 100 questions, but I will ask you 50 questions. So it means that the questions are going to be selected randomly from the database. It is also likely that you will get different questions than your friend had already. So I strongly suggest you not to focus on your friend's paper on answers, but your own answers. This is what I'm suggesting. That's why I'm going to spend extreme amount of time to prepare that exam to be sure that students are not cheating. Okay, Thomas, please ask again.
I forgot what I wanted to ask previously, but I have one new question. Will the questions be sequential, or we can like go back to the questions that we have missed maybe?
I couldn't follow. What do you mean spatial? I didn't get it.
Sequential. When you go to the next question, you cannot turn back to the previous one.
I see. Okay, I did it before, but it created lots of complications for the students because some students, I mean, not so much, all the students are, they like to give the answer. If they are not able to answer that question and if find it a little bit difficult, they just leave it and they will go for the next, okay? And at the end of the exam, when they finish the easy ones, they like to focus on the difficult ones. This is what I know. So that's why probably I am going to allow you to, okay, shuffle between the questions.
Okay, good.
Do you prefer the other one? Other way?
No, this one is good because if we are limited of time and it can be stressful.
I see. Otherwise, it's going to be more challenging.
And one more question: what about the invigilation? Will it be like on the midterm? So will you keep that system with Zoom?
Yeah, it is.
Supervising.
It is the same thing. You are going to join Zoom first. You will turn on your camera, and then you will join Moodle, and then exam will start, and you will take your exam while we are watching you on Zoom.
And will you provide formulas, like formula sheet? Or no?
I think I can do that.
Okay.
A formula page. Yes, we can do that. Yeah. Yes,
would be great.
But the advantage is that you are not going to get too complicated questions to solve. Okay, those are going to be easy to solve problems. I mean, typically one question is supposed to be solved in 1 minute. Okay, this is the balance. I mean, if I ask you 50 questions, you will have 50 minutes. Some questions are going to be like 1 second question, like true and false. But of course, you should answer those questions very quickly, and you should spend your time for other difficult questions that requires a little bit timing on calculations. Yeah, this is what I am thinking. This is what I am planning. Okay, any other questions, please? No more questions. Okay, guys, it was interesting experience this year. I always say that. I mean, not always say, but I am having a kind of satisfactory ending. I mean, when the course is over, I feel myself mostly satisfied very well. But this time I am not feeling the same thing because of this online teaching. I am feeling that you didn't get the best knowledge as you are supposed to get. But I hope we are going to go back as soon as possible. And again, if you have any future plan for your future career to focus on water engineering, I strongly suggest you to take the course water supply engineering. Then you should not worry about the fundamental knowledge, because I am going to also cover some topics later, okay, in that course too. I will provide you lots of working and practical information how we can make such designs in that course. And as I told you, that course is totally different. And in previous year, the students took that course and they commented very positively, and they said that this is one of the best and most interesting course they have ever had, because I am not providing you theoretical information or some practical. We are just following exactly how a project should go. Okay, we are starting from the first stage of design, and then we will go together by making your own design step by step. And at that, you are going to have a full infrastructure design, and every student will do it individually. There will be no group work. So this is also interesting, a bit challenging, but very good engineering practice for you. Okay, so it is over. Guys.
May I ask
Yes, please, Aktana.
about the final? You just said that we are going to have 15 questions in 15 minutes. Isn't it too much?
I said 50. 50.
50 questions.
Yes.
Oh, okay.
And 50 minutes.
Isn't it too much? I mean,
Too much of what?
of stress on us.
Why? But this is, as I told you, that this is the reality of engineering. I mean, if you go to certification programs for any engineering, you are going to get similar type of questions. Why it is too much? I think paper-based exam is more stressful, but as I told you that I am not happy with that exam. Aktana, I don't want to take the hard way. And if you really like to see what I'm talking, for example, there are like 20, 25 students already identified. Actually, it is not only me. I mean, those students are also identified in the other programs or other courses. You have no idea, but you have a big trouble now, guys. We are working on it. And some students are going to be punished. Trust me. I see that there are lots of students in the classroom at the moment cheating and taking the advantage of these online things. I mean, no one is stupid, including the professors, but we are just tolerating it by some legitimate reasons. Okay, and this time I will not do a kind of paper-based exam. It's not going to happen. Sorry. You will take multiple choice exam, and in terms of questions, don't worry. They are going to be easy to answer questions. Okay. Okay. So I gave one example. Okay, if you want, I can give another example. For example, if I ask you a questions, there is a water flow, and that flow is having a kind of hump on the bottom. It's an open channel flow, and on the hump there is a rising up. Okay, so the question is that what should be the flow type in the upstream? Is it supercritical or subcritical? Okay, so this kind of questions you are going to get it. It's going to test your knowledge. Okay, not only problem solving skills. So study hard. It is also interesting, guys. I am making these courses. Let me check now how many students we have. It is interesting discussion. Okay, I'm going to stop recording now because these are the things I don't want to record.